Light is something we interact with every day, yet rarely think about in detail. From homes and offices to streets, factories, and cities at night, light shapes how we see, move, and experience the world around us. At its core, light is a form of energy. It travels as electromagnetic waves, moving at incredible speed and carrying information about the objects it touches. When light reaches our eyes, our brain translates it into images, colors, depth, and motion, allowing us to understand our surroundings. For most of human history, light was limited to natural sources such as the sun, fire, and candles. Daily life followed the rhythm of daylight. As societies grew more complex, the need for reliable artificial lighting became essential. Light extended working hours, improved safety, and allowed human activity to continue long after sunset. Artificial light works by converting energy into visible illumination. While different technologies achieve this in different ways, they all serve the same purpose: to create controlled, consistent light whenever it is needed. This ability changed how people live, work, and build modern infrastructure. Light also influences how materials, colors, and spaces are perceived. The intensity and quality of light affect comfort, focus, and visibility. Because of this, artificial lighting must be carefully designed to remain stable, efficient, and safe over long periods of use. One of the most familiar forms of artificial lighting is the light bulb. Simple in appearance, yet the result of precise engineering and industrial production. Behind every bulb is a carefully balanced combination of materials, design, and manufacturing techniques. In the following sections, we take a closer look at how light bulbs are made and how modern industry transforms energy into light on a global scale.
The production of light bulbs is a process where material science, precision manufacturing, and energy conversion come together. While the final product appears simple, each bulb is the result of carefully coordinated steps designed to ensure reliability, efficiency, and safety. The process begins with glass. Specialized glass materials are heated to extremely high temperatures until they become soft and workable. The molten glass is then shaped into the familiar bulb form using controlled molds and air pressure. The glass must remain thin and uniform while also being strong enough to withstand heat during operation. Once the shape is formed, the glass is cooled in a controlled environment. This step is critical as uneven cooling can create internal stress and reduce durability. Proper cooling ensures the bulb remains resistant to cracking during transport and everyday use. After the glass shell is prepared, internal components are installed. These components are responsible for producing light once electricity flows through the system. Precision is essential, as small inconsistencies can affect brightness, efficiency, and lifespan. The bulb is then sealed to protect the internal components from air and moisture. This sealed environment allows the light-producing elements to operate reliably over long periods of time. Any imperfections at this stage can shorten the lifespan of the bulb. Once assembled, light bulbs undergo testing. Each unit is checked for brightness, stability, and safety. Only bulbs that meet strict standards move on to packaging and distribution, ensuring consistent performance in everyday environments. At its core, a light bulb converts electrical energy into visible light. This process is never perfectly efficient, as some energy is lost as heat. Improving efficiency has therefore been a central goal in lighting development over time. As lighting technology evolved, global demand for electricity increased. Powering homes, cities, and industries required large-scale energy production systems, raising questions about sustainability and long-term energy use. This is where renewable energy sources such as solar and wind power become closely connected to lighting. Solar panels convert sunlight into electricity, while wind turbines generate power from moving air. Both feed electricity into the same grids that supply lighting systems. Efficient lighting reduces overall energy demand. making renewable systems more effective. When less electricity is required to produce the same amount of light, solar and wind energy can support a larger share of daily consumption. In industrial environments, lighting remains essential for safety and productivity. As these environments grow worldwide, the energy required for lighting becomes significant, reinforcing the importance of efficiency. In this context, light bulbs represent more than illumination. They stand at the intersection of manufacturing, energy use, and sustainability, connecting everyday technology with the future of clean energy systems. The development of artificial lighting did not happen in isolation. It evolved alongside industrial growth, urban expansion, and the increasing demand for reliable energy. As more spaces required illumination, lighting became an essential component of modern infrastructure. Factories, transportation systems, and public areas rely on consistent light to function efficiently. This demand places continuous pressure on energy systems, making the way light is produced and consumed increasingly important. Over time, lighting technologies have been refined to reduce energy loss while maintaining performance and reliability. Manufacturing plays a key role in this process. The materials used, the precision of assembly, and the durability of components all influence how efficiently a light source operates over its lifetime. A well-manufactured product reduces maintenance, minimizes waste, and lowers long-term energy demand. As energy consumption increased globally, the focus shifted toward more sustainable power generation. Renewable energy sources such as solar and wind emerged as viable alternatives to traditional systems. These sources produce electricity without direct emissions, but their output depends on natural conditions. Because of this variability, efficiency on the consumption side becomes critical. Lighting systems that require less energy allow renewable power to support a greater share of daily demand. Each reduction in energy use helps stabilize power grids and improves the effectiveness of renewable generation. In modern systems, electricity generated by solar panels and wind turbines flows through the same networks that power lighting in homes, factories, and cities. The connection between energy production and lighting is direct and constant. Improvements in one area immediately affect the other. As renewable infrastructure expands, lighting continues to play a strategic role in managing energy loads. Large-scale lighting systems are often among the first areas optimized to reduce consumption, as even small efficiency gains can have a significant cumulative effect. This relationship continues to shape how lighting products are designed and manufactured. Efficiency, longevity, and reliability are no longer optional features, but essential requirements in a world transitioning toward cleaner energy systems. Light, once limited by natural cycles, is now part of a complex network connecting industry, technology, and sustainable power. Through careful manufacturing and efficient energy use, lighting remains a central element in the evolution of modern society. Light may appear simple, but its impact reaches far beyond illumination. From the materials used in manufacturing to the energy systems that power it, lighting reflects how technology, industry, and efficiency evolve together. Each light source represents a balance between design, production, and energy use. As manufacturing improves and energy systems become cleaner, lighting continues to adapt, reducing waste while maintaining reliability. In a world increasingly shaped by renewable energy, efficient lighting plays a critical role. It helps stabilize power systems, supports sustainable infrastructure, and connects everyday technology to long-term environmental goals. As energy production and consumption become more interconnected, even small improvements in efficiency can have lasting effects. Reduced demand allows power systems to operate more flexibly, supporting the integration of renewable sources such as solar and wind without compromising reliability. Lighting also influences how energy is used at a global scale. When millions of efficient light sources replace older technologies, the cumulative impact becomes significant. This shift reduces strain on power grids and lowers overall resource consumption, contributing to more resilient infrastructure. What began as a solution to darkness has become an essential part of modern society. Light now stands at the center of a complex relationship between manufacturing, energy, and technological progress. shaping how people live, work, and move forward in a world increasingly focused on sustainability.